You've been here. The video freezes, the little circle spins, and the longer it spins, the faster your blood pressure climbs. When this happens, we usually blame a single plastic box sitting in the corner. We treat the internet like plumbing, assuming this one little router just turns on a tap and the Wi-Fi simply flows. But that box isn't creating the internet. Between the wall and your screen lies a highly specialized gauntlet of separate hardware, each executing a specific job in fractions of a second. Treating that entire chain as one magic box is exactly why we waste hundreds of dollars upgrading the wrong gear. To actually fix a dead network, we have to track the literal physical journey of a single piece of data. The journey begins at the edge of your home. Your internet service provider pipes data down your street through copper coaxial cables, phone lines, or fiber optics. But this data is traveling as analog signals, a language your computer simply does not speak. That's where the modem steps in. This is the first gatekeeper. Its entire job is to bridge the gap between the chaotic analog frequencies of the outside world and the digital environment of your house. This diagram shows demodulation. The modem takes that flowing analog wave, and as it hits the vertical line, chops it into ones and zeros. When uploading, the exact reverse happens. It pushes ones and zeros back through, modulating them into analog signals. Without this constant two-way translation, your home network is completely cut off from the global internet. Once that data is digitized and readable, it immediately slams into the firewall. If the modem is the translator, the firewall is the bouncer. Every piece of data arrives in a tiny packet. The firewall inspects every single one, cross-referencing where it came from, where it's going, and what protocol it's using. If it detects an unauthorized access attempt or recognizes a malicious IP address, it drops the packet immediately. The modem and firewall provide the physical and digital filtering every other device in the chain relies on. Without the first, data is unintelligible noise. Without the second, your internal devices are sitting ducks. Now the data is clean, translated, and safe. It moves to the router. People constantly confuse the router with the modem, but the router does not actually provide your internet connection. Its primary, critical job is strictly traffic management. Your ISP assigns a single public IP address. The router uses network address translation to splinter that connection, assigning unique local IP addresses to every device. Now, a heavy video stream can perfectly reach your smart TV, while a tiny email simultaneously reaches your phone. The router is the architect of your local area network. It builds the internal roads and programs the traffic lights, so 50 different devices can safely share one external highway connection. But the standard router has physical limitations. It usually only has 4 or 5 Ethernet ports on the back, and its built-in Wi-Fi can only push a signal so far before you hit dead zones at the edges of your home. When you run out of wired ports, you add a switch. Decades ago, people used network hubs to do this, but hubs were inefficient. They blasted data to every connected wire and clogged the entire system. This top-down view shows why modern switches replaced hubs. A switch maintains a directory of hardware addresses. When a packet arrives, it routes that data strictly to port 4, leaving the other 7 ports completely inactive. This guarantees dedicated bandwidth to a single connection. To solve wireless limitations, you add a wireless access point, or WAP. An access point doesn't route traffic. It acts as a bridge, taking a hardwired Ethernet connection and broadcasting it to cover a wide area, which finally brings the data to the absolute end of the line, the physical hardware buried inside your device.
The Network Interface Card, or NIC. To pull radio waves out of the air and turn them back into digital data, the NIC relies on its MAC address. This is a unique, factory-burned hardware fingerprint that allows the network to identify your specific phone or laptop out of billions of devices. The simple act of loading a web page represents the successful completion of a highly complex, multi-device relay race, executed flawlessly in milliseconds. So why do we still think of this whole process as a single magic box? Because internet service providers cram the modem, a basic firewall, and a router into one cheap plastic shell to cut down on support calls. This design hides the true complexity of the system. Once you see the separation of powers, you can target your specific bottlenecks instead of blindly upgrading everything. This diagram shows how modular a network can be. If your bedroom has a dead zone, you don't need to pay for a higher tier of internet service. You add a dedicated access point.
If you build a gaming room, you run a cable and install a cheap switch. Paying for gigabit download speeds is useless if that incoming data just crashes into an ancient, low-capacity router buried in your closet. Recognizing these distinct roles removes the guesswork from network troubleshooting. Instead of paying for speed you can't use, you can finally identify, isolate, and control every link in the chain.